Let's continue with a few more problems that involve the sum and difference identities with sine and cosine. So here's problem number 4. It asks us to rewrite in terms of sine x and cosine x the expression cosine of x minus 5 pi over 3. So rewrite in terms of means here we want our answer to just involve sine x, cosine x, maybe some constants in the end. And we're starting out with this cosine of x minus 5 pi over 3. That should look like a cosine of alpha minus beta form to you. And so even, I might wonder where the heck is this going to go? Well, I know I can start out using my identity for cosine of alpha minus beta because I have cosine of a difference here. So I'm going to refer to my identities, my identity sheet, where they're summed up. So I can just copy this down. You don't have to have it memorized, in my class at least. And so cosine of alpha minus beta was equal to cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. And what I'm going to do is now replace alpha with x and beta with 5 pi over 3. So I'm going to write out cosine of x minus 5 pi over 3 with those substitutions being made. So instead of cosine alpha, here I write cosine of x. Instead of cosine beta, I multiply by cosine of 5 pi over 3 plus sine of x sine of 5 pi over 3. Now I can go a little bit further because we can actually come up with values for the cosine of 5 pi over 3 and the sine of 5 pi over 3. So I'm going to, on my next line, I'm going to have cosine x times the cosine of 5 pi over 3 plus the sine of x times the value of the sine of 5 pi over 3. Now let's think about that angle 5 pi over 3. I'm going to go back to the unit circle here, and 5 pi over 3 is almost 6 pi over 3. It's almost one full circle. It's actually going to have its terminal side in quadrant 4. Its reference angle is pi over 3, or 60 degrees. And so that means its sine and cosine are related to the sine and cosine of pi over 3, right? We know the cosine of pi over 3 is a half. We got that memorized. The sine of pi over 3 is square root of 3 over 2. Now the difference here with 5 pi over 3 is we're in quadrant 4, so the cosine will be positive, so the cosine is just positive a half, but the sine will be negative. Sine is going to be negative square root of 3 over 2. And so now when I go back to my problem here, I can replace cosine of 5 pi over 3 with the number a half, sine 5 pi over 3 with the number negative square root of 3 over 2. And so we're going to take this just one step further here. I'm just going to rewrite it slightly with the constants times the functions with the constants in front. So I can rewrite this as 1/2 times cosine x. And the second term I can write as minus square root of 3 over 2 times sine x. And that's all we want here. We've rewritten the original expression in terms of cosine x and sine x. So that's number 4. Let's move on to number 5. We want to simplify secant of pi minus theta. So that kind of weird to see secant here because we don't have an identity involving secant, but I think we've had experience before where we can rewrite a secant as 1 over a cosine, right? This is equivalent to 1 over cosine of pi minus theta. And we want to write it that way because if we have cosine of pi minus theta involved, that makes me think of this cosine of alpha minus beta identity again. And the identity is actually right up there in red, higher up on the page. So I won't recopy it again. Now what I'm going to do is I still have 1 over, but it's the denominator of this fraction that I'm going to expand out using the cosine of alpha minus beta identity, just like in red up at the top. But the alpha now is pi, and the beta is theta. So I write cosine pi cosine theta, copying the first 2 terms here, plus, it'll be the product of the 2 signs, right? Sine pi sine theta. Now I can evaluate cosine pi in sine pi, because we know that pi, same as 180 degrees. On the unit circle, this point has coordinates -1, 0. So the cosine of pi is -1. The sine of pi is 0. So this big mess in the denominator becomes, let's see, altogether we have 1 over -1 cosine theta plus 0 times sine theta. So that whole second term drops out in the denominator. We just have 1 over minus cosine theta. We can pull the minus sign out in front, right? That is minus 1 over cosine theta. And I'm actually perfectly happy if you leave your answer that way. That's a simplified form. But if you want, you could also rewrite that 1 over cosine theta as secant theta. And it's sort of pretty to write the answer in terms of secant because we started out with a secant. So we could also write that as minus secant theta. And there, we're done with number 5. We got a couple more that we're going to do, and a little bit more intense now. I'd say these are, next couple are probably some of the most challenging problems we're going to see in the whole course here. Number 6, given that sine of A is -2/3 and cosine of B is 5/8, where A and B are both in the interval 3 pi over 2 to 2 pi, find sine of A plus B. I'm using A and B here mainly because the textbook starts using A and B in some of the exercises, but it's just like alpha and beta. I mean, sine of A plus B is just like sine of alpha plus beta. And so we're gonna, certainly seems like we want to work with the identity for the sine of the sum of 2 angles here, since we want to find sine of A plus B. And again, I can just copy the identity down from my formula sheet. I'm going to use A and B instead of alpha and beta. So when I copy the identity down from my identity list, it's sine A cosine B plus cosine A sine B. And so we got 4 different trig function values involved here. Now notice we actually know what sine A is. They're telling us what sine A is, so that's -2/3. And we know what cosine B is. That's 5/8, plugging in. But then I have to add on to that product cosine A times sine of B. And we don't have either one of those values. So we actually, we need to find cosine A and sine B. We need to figure out what those are, and then we need to plug them in and put our final answer together here. Now, we know that sine A is negative 2/3, and we need to find cosine A. And I'm just going to write this down on one side. And now this is the kind of situation we've seen before where we know the sine of an angle. We want to find the cosine. This is when we use that most famous trig identity. Sine squared plus cosine squared equals 1. I can plug in my value as sine, negative 2/3 squared, plus cosine of A squared is equal to 1. So I'm going to use this identity now to solve for cosine of A. Negative 2/3 squared is positive 4/9, plus cosine A squared is 1. So cosine A squared is 1 minus 4/9. That's going to be 5/9. And now I can take square roots. Cosine A is going to be plus or minus the square root of 5/9. And I got to make a choice now about positive or negative value. Way up here in the fine print for the problem, we were told that both A and B were in the interval from 3 pi over 2 to 2 pi. That's quadrant 4. So these are both angles with terminal sides in quadrant 4. And that becomes relevant down here, because in quadrant 4, cosine is always positive. So cosine of A has to be positive. That's square root of 5 over 3. I can take that square root of 9 in the denominator. And I got my value for cosine of A that I can plug in up above, square root of 5 over 3. And now we still need sine B. And I'm going to use the fact that cosine B is 5/8. That was given to us in the statement of the problem. And we got to find sine B. So it's going to be a very similar kind of calculation. Now we're going to use sine squared B plus cosine squared B equals 1. I'm going to plug in my value of cosine B, 5/8 squared equals 1. So sine B squared plus 25/64 is 1. Sine B squared is 1 minus 25/64. So that's, let's see, 64/64 minus 25/64 is going to be 39/64, a little bit of fraction arithmetic there. Sine B, now I can take square roots, is plus or minus the square root of 39/64. And again, now I gotta choose a plus or minus sign. But we're both A and B were in quadrant 4 from the statement of the problem. And if B is in quadrant 4, we want the sign here. Sign is going to be negative in quadrant 4. So sine of B is actually a negative. Now square root of 39 I can't simplify, but square root of 64 below is 8. So kind of an ugly looking fraction there, but that negative square root of 39 over 8 is what I'm going to plug in up above for sine b. A negative square root of 39 over 8. And you can leave this type of answer this way. I don't want you to have to go through all the fraction manipulations. So I'd be perfectly happy to see an answer written that way, but I'll clean it up a little bit here. Let's see, we can write this as negative 10/24ths. It's going to be minus. I can multiply those square roots together. They don't simplify separately. 5 times 39 is 195 over 24. So this answer could be written as negative 10 minus the square root of 195 all over a common denominator of 24. So it didn't really clean things up very much. I'm going to try to zoom out a bit so we can get the whole problem here on the screen. And so that's pretty intense. That's problem number 6. We're going to do one more of these together in this video. Number 7 is to find, let's look back in, find cosine of cosine inverse of negative 3/5 plus sine inverse of 1/3. So here, oh boy, not only do we have one of these cosine of the sum identities to deal with, but we also have inverse trig functions being invoked here. Now, the key to seeing through this mess is to realize that we can think of that cosine inverse as one angle, like alpha, and the sine inverse as another angle, beta. So what we're actually trying to do here is we're trying to find cosine of alpha plus beta. That's how we can, one way we can interpret that mess. And so cosine of alpha plus beta is applying my identity, cosine alpha, cosine beta. For cosine of the sum, there's a minus sign, minus sine alpha, sine beta. Okay? Now what we're going to do is we're actually going to figure out each of these four separately and just plug them in, kind of like the previous problem. Okay? And so we got some work to do now. Now, what do we know? What I'm saying up here is, when I labeled the alpha and the beta, I'm saying let alpha be equal to cosine inverse of negative 3/5. And remember what that means. That means that cosine, regular cosine of alpha is the angle, is negative 3/5. And it means that alpha is in, for the inverse cosine, alpha is going to be in the interval from 0 to pi. And, oh, well, cosine alpha is negative 3/5. That's this first part of our formula, right? We need cosine alpha. There it is. So we actually can just fill that right in. We're also going to let beta be equal to sine inverse of 1/3. So that means that sine beta is 1/3, and beta is in, now beta's in a different interval, right? With inverse sine, we use the negative pi over 2 to pi over 2 interval. And so that also gives me one of these values that I need, sine beta up above. I don't have cosine beta yet, minus Sine alpha, I don't have that yet, but I got sine beta is 1/3, so I already have 2 of the 4 trig function values we need to plug in to get our cosine of the sum. And now, though, we got to find cosine beta and sine alpha, so we need to find cosine beta and sine alpha to be able to plug them in up above. And we can, again, use our most famous trig identity to help us out here. Let's maybe just I'm going to do sine alpha first here, because sine squared alpha plus cosine squared alpha is equal to 1 from the Pythagorean identity. We have a value for cosine alpha. So sine of alpha squared plus -3/5 squared is 1. Sine of alpha squared plus, that's 9/25 is equal to 1. Sine of alpha squared is 1 minus 9/25. That's 25/25 minus 9/25 is 16/25. So sine of alpha is plus or minus the square root of 16/25. And, oh, this comes out nice, right? Sine of alpha is now, when I take square roots, I'm going to have 4/5. And I got to think, do I want a plus or minus sign here? Here's where quadrants come into play. Let's see, alpha we know is in quadrant 1 or 2. Actually, we can say a little bit more, but really that's all we need to know here, quadrant 1 or 2 from that interval. So if we're in quadrant 1 or 2, we know to choose the plus sign for sine, because sine is positive in both quadrant 1 or 2. So sine of alpha is 4/5. I can fill that in up above. And now I also need to find cosine of beta, right? So we're going to use sine squared beta plus cosine squared beta equals 1. And here's where I'm going to plug in my sine of beta is 1/3 squared plus cosine squared beta equals 1. That's 1/9 plus cosine squared beta equals 1. Cosine squared beta is 1 minus 1/9. So cosine squared beta is going to be 9/9 minus what? That's 8/9. Cosine beta is plus or minus the square root of 8/9. And now we got to think about our quadrant for beta. Beta is in quadrant 4 or 1 because it came out of the inverse sine function. And the funny thing is, for quadrant 1 or 4, when we come down to taking a value of cosine, well, that's positive. Cosine is positive in quadrant 1 or 4, so we have a positive square root of 8/3, and we can simplify that to 2 square root of 2/3 is cosine of beta, because square root of 8 is 2 square root of 3, 2 square root of 2. And so I'm going to take my value, plug it in up above, 2 square root of 2/3. And again, there, that's kind of a mess of fractions. I'm okay if you leave it in that form. But if you want to simplify, that's -6 square root of 2/15 minus 4/15, which could be written as -6 square root of 2 minus 4 all over 15. And no canceling here. Again, once I combine, I can't reduce because there's no common factor from the numerator and denominator. All right, so that's quite an intense problem. Let me back out a bit so we can get the whole problem here a little bit more. And all right, I think that's it for this video.